morning, good morning. How's everyone doing this morning? It is so exciting to be back here in San Francisco with so many of our press and analysts and partners and friends in the audience. And welcome to all of you who are joining us across the world. We have a lot of new products and exciting news to share with you today, so let's go ahead and get started. At AMD, we're focused on pushing the envelope in high performance and adaptive computing to create solutions to the world's most important challenges. From cloud and enterprise data centers to 5G networks to AI, automotive, healthcare, PCs, and so much more, AMD technology is truly everywhere, and we're touching the lives of billions of people every day. Today, we're here to talk about our newest EPYC data center processors, our upcoming Instinct accelerators, and our growing AI software ecosystem. Now, taking a look at modern data centers, what you really need is the highest performance compute engines across the board. Today, we lead the industry with our EPYC processors, which are the highest performing processors available. We also offer the industry's broadest portfolio, which allows us to really optimize for the different workloads in the data center. Whether you're talking about Instinct GPU accelerators built for HPC and AI, or you're talking about FPGAs or adaptive SoCs or smart NICs and DPUs from our Xilinx and Pensando acquisitions. What we'll show you today is how we bring all that together and really expand our portfolio with our next generation data center and our AI offerings. Now, since launching EPYC in 2017, we have been laser focused on building the industry's best data center CPUs. EPYC is now the industry standard in the cloud, given our leadership performance and TCO across a wide range of workloads. Every major cloud provider has deployed EPYC for their internal workloads as well as their customer-facing instances. Today, there are more than 640 EPYC instances available globally, with another 200 on track to launch by the end of the year. Now, looking at the enterprise, EPYC adoption is also growing, and especially for the most demanding and technical workloads. Whether you're talking about financial services or telecom or technology or manufacturing or automotive customers and many, many more, they're really choosing EPYC based on our performance, our energy efficiency, and our better total cost of ownership. And that momentum is just growing as we ramp our 4th gen EPYC Genoa processors. Genoa features up to 96 high-performance 5nm Zen 4 cores. It has the latest I/O that includes PCI Gen 5, 12 channels of DDR5 memory, and support for CXL. We launched Genoa actually last November, and it had leadership performance and efficiency. And since then, there have been other products that have come to market. But if you look today, Genoa is still by far the highest performance and the most efficient processor in the industry. So let's just take a look at some of those metrics for Genoa. Starting first with the cloud, integer performance is key. Using spec int rate and comparing to the competition's top of stack, EPYC delivers 1.8 times more performance. Looking at the enterprise, if you look across Java workloads or virtualization or ERP workloads, 4th gen EPYC is up to 1.9 times faster. And perhaps the most important piece is in modern data centers, energy consumption has become just as important as overall performance. And when we designed Genoa, we actually designed that with that in mind. The idea that, yes, we want leadership performance, but we must have best-in-class energy efficiency. And that's what 4th gen EPYC does. We deliver up to 1.8 times more performance per watt than the industry, compared to using the industry standard spec power benchmark. And what that means is that Genoa is by far the best choice for anybody who cares about sustainability. So when we talk to customers, many of them are telling us, actually, they need to refresh their data centers, and they really need to consolidate and get a better footprint and get a better operating cost. This is actually the perfect place for Genoa, and it really shines for these types of consolidations. Now, looking at AI, we're going to talk about GPUs shortly, but actually today, the vast majority of AI workloads are actually being run on CPUs. And Genoa is also the best CPU for AI. The best way to look at AI performance is actually to look at a broad set of end-to-end workloads. And so we use the industry standard TPCXA benchmark that actually looks at end-to-end AI performance across 10 different use cases and a host of different algorithms. And what we see in this case is EPYC is 1.9 times more performant than the competition. Now, you can see I'm tremendously excited about Genoa and all of the applications that our customers are running on Genoa, but it's best to hear directly from our partners. So I'm really excited to introduce our first guest, one of our most important cloud partners, to talk about how they're deploying Genoa in the public cloud. Please welcome our good friend, AWS Vice President Dave Brown. Dave.
Hey, Lisa.
It is so wonderful to see you. Thank you so much for being here with us today.
Great to see you as well. Thank you.
Yeah, we have been, so much has been going on. You know, we've been on this long journey in partnership together. Can you talk a little bit about our partnership?
Absolutely, Lisa. And thank you for having me, and thank you for the opportunity of being here today. I'm excited to talk about our partnership and how AWS and AMD are continuing to collaborate to advance cloud technology for our customers. At AWS, we're constantly innovating on behalf of our customers and have built the most reliable and secure global cloud infrastructure with the broadest and deepest portfolio of instances to support virtually every type of customer workload. AMD and AWS have been on a journey together since 2018, when AWS was the first to introduce the AMD EPYC-based instance in the cloud, delivering 10% cost savings over comparable x86 EC2 instances. And as customers used and benefited from these instances, they requested additional AMD-based instance types to run a broader set of applications. And together, we have introduced over 100 AMD EPYC-based Amazon EC2 instances for general-purpose, compute-intensive, and memory-intensive workloads. And just last year, we introduced our first instance optimized specifically for high-performance computing-based AMD processors, HPC-6A. And that delivered up to 65% better performance over comparable EC2 x86-based compute-optimized instances for workloads such as computational fluid dynamics.
Dave, we love the work with your team. I mean, it has been such a journey over all of these years, and we love the 100+ instances. Now, the breadth of your offerings is amazing. Now, we always talk about what can we do with our joint customers, and how do they benefit from our technology? So can you tell us a little bit about customers?
Absolutely. So we have a broad range of customers, and they've benefited significantly from the cost savings with AMD-based EC2 instances. A few examples of how enterprise customers have invested these cost savings into innovation to improve their businesses include TrueCar, a digital automotive marketplace, one of my favorite tools. They sought ways to operate more efficiently and increase development velocity so they could invest the money saved into innovating for car buying experience. And TrueCar optimized its AWS cloud infrastructure by up to 25% from a combination of choosing the AMD instance family for its core infrastructure, as well as right-sizing instances with AWS recommendation tools. And Sprinkler, another customer, is a purpose-built web platform for businesses to manage customer experiences on modern channels. With the scale at which Sprinkler operates, it is to optimize its robust architecture for cost and performance. Sprinkler has been an early adopter of our first-generation AMD-based EC2 instances for general-purpose workloads, our M5A instance. And when they moved to Amazon EC2 M6A, the next generation, Sprinkler saw 22% faster performance and 24% cost savings over the previous generation. And then in the HPC space, DTN, they run weather and data models that deliver sophisticated, high-resolution outputs that require continuous processing for vast amounts of data from inputs across the globe. DTN uses Amazon EC2's HPC-6A instances, powered by AMD's EPYC processors, to run computer-intensive HPC workloads. And through the agility, elasticity, and efficiency of running HPC workloads on AWS, it has effectively doubled its high-resolution global weather modeling capacity from 2 times a day to 4 times a day.
I love what we're doing together with customers. It's really great to hear those examples. I think both AMD and Amazon, we really share this passion for enabling our customers to do more with our technology. Now, I'm even more excited, Dave, about what we're doing next together. So can you talk a little bit about what's next for our partnership?
Absolutely, Lisa. Well, one of the things we continue to see is increasing demand from customers to run workloads faster while getting better price performance in AWS. And to help address customer needs, we're building new EC2 instances enabled by the unique combination of the 4th generation AMD EPYC processors together with the AWS Nitrous system. Now, the AWS Nitro system is the foundation for every single EC2 instance, enabling us to deliver performant, secure, and efficient infrastructure. And by combining the 4th-generation AMD EPYC processors and the AWS Nitro system, we've unleashed the full capability of the next-gen AMD processors and deliver a significant leap in performance for our customers.
Yeah, I mean, look, we're so excited about what we're doing together with you, with Genoa, with Nitro, with all of your resources at AWS. Let's talk about what that means for customers.
Well, today, we are very excited to announce the preview of Amazon EC2 M7a general-purpose instances powered by the 4th-generation AMD EPYC processor. And based on our spec...
They're kind of excited about that,
well, so are we.
Yeah.
And based on our spec-in benchmarks, M7a has been designed to provide the best x86 performance and price performance per vCPU within the Amazon EC2 x86 general-purpose instance family. M7a instances offer a major leap in performance with up to 50% more compute performance than M6a, the previous generation. We think workloads, including financial applications, application servers, video transcoding, simulation modeling, they would all benefit from the M7a instance. M7a instances also offer new processor capabilities such as AVX3512, VNNI, bfloat16 to enable customers to get additional performance and bring an even broader range of workloads to AWS. And as I mentioned earlier, M7a instances are in preview today. Customers can sign up for the preview and with general availability coming in Q3. And of course, AWS will be bringing Genoa to more of EC2 instances so our customers can do more with this new level of performance over time. Elisa, we're also very excited that AMD will be using these instances for your own workloads.
Yeah, I mean, absolutely, Dave. By the way, did you guys hear that he said 50% more compute performance on M7a? I mean, it's just amazing gen-on-gen performance, and we're so excited that we're going to see Genoa throughout EC2. We truly appreciate the partnership with AWS, Dave. You know, you're such an important partner for our own IT environment as well. So we're using AWS today for our data analytics workloads, and we appreciate all of your flexibility and capabilities there. But with the new Genoa expanded instances, we're going to expand our partnership to include some of our highest performing technical workloads, such as EDA. So thank you.
Fantastic. Well, Lisa, it's been really great to be here with you to kick off this event. We're excited about the performance and the price performance benefits we're able to deliver for our customers, and I can't wait to see how our joint customers will innovate with this technology.
Thank you so much, Dave.
Thanks
for being here, and thanks for your partnership.
Thank you.
We're super excited with the new M7a Genoa instances reaching public preview, and we really believe that this is a step function improvement in performance that you can get in the public cloud. We're looking forward to delivering even more capabilities for our customers with these new instances. And when you look across the industry, we're actually really pleased with the response that we're getting on Genoa based on the leadership and also delivering across a broad number of general-purpose server workloads. So I also want to say today that Oracle is announcing today also new Genoa standard, HPC, and dense I/O instances that are expected to enter general production starting in July. Now, I'll say overall, Genoa is ramping very nicely, and you'll see a number of other public instance and customers coming online over the coming weeks and months. But what I did say earlier is that data center workloads are becoming increasingly more specialized, requiring optimized computing solutions across CPUs, DPUs, and of course, AI accelerators. And that's what makes AMD special. Our breadth of our data center and AI compute portfolio actually provides a significant advantage because you can use the right compute for the right workload. So now let's talk about cloud-native computing. Cloud-native workloads are actually a very fast-growing set of applications that are really, let's call it, born in the cloud. They're designed to take full advantage of new cloud computing frameworks, and they run as kind of like microservices. So you split up sort of large amounts of code, and you put them into smaller processes, and then they can be scaled independently to enable 24/7 uptime. The optimum design point for these processors are actually different than general-purpose computing. They're actually very throughput-oriented, and they benefit from the highest density and the best energy efficiency. So all of these factors actually drove the development of Bergamo. Bergamo is actually our first EPYC processor designed specifically for cloud workloads. So let me tell you a little bit about Bergamo. Bergamo leverages all of the platform infrastructure that we already developed for Genoa, and it supports the same next-gen memory and the same I/O capabilities, but it allows us, with this design point, to expand to 128 cores per socket for leadership performance and energy efficiency in the cloud. Now, I'm very happy to show you, Drew, can I have my chip, please? As you guys know, I love my chips. Our chips. I am very happy to show you Bergamo. This is our new cloud-native processor, and what we have here is there's actually a new compute die. So the compute die is different from Genoa, using our chiplet technology. Each of these 8 compute dies has 16 of our Zen 4 cores, and then we use the same 6-nanometer I/O die used by Genoa in the center. Thank you. So let me talk a little bit about how we do this. If you take a look at the core, the Zen 4C core is actually an enhanced version of the Zen 4 core. It's actually a great example of our modular design approach. When we originally designed the Zen 4 core, it was actually optimized for the highest performance per core. Zen 4C is actually optimized for the sweet spot of performance and power, and that actually is what gives us the much better density and energy efficiency. And the way we accomplish this is that we actually start from the exact same RTL design as Zen 4, and that gives us 100% software compatibility. And then we optimize the physical implementation of Zen 4C for power and area, and we also redesign the L3 cache hierarchy for greater throughput. So if you put all this together, the result is a design that has 35% smaller area and substantially better performance per watt. Now, from a product standpoint, what does this mean? What it means is the only real difference between Genoa and Bergamo is the CCD core chiplet. So we use the same socket, we swap out the Genoa CPU chiplet, and we put in the Bergamo CPU chiplet. And what you have is each of the 8 compute chiplets on Bergamo contains twice the number of cores as was on Genoa. And that's how we get to 128 cores per socket. But importantly, as I said, it's fully software compatible, and it's also fully platform compatible with Genoa. And what that means for customers is they can easily deploy either Bergamo or Genoa, depending on their overall compute needs and their overall workloads. And so we really tried to leverage the overall platform investment in AMD. So let me show you some of the performance metrics on Bergamo. If you compare Bergamo to our competition's top of stack, what you'll see is just incredible performance. We're delivering up to 2.6 times more performance across a wide range of cloud-native applications, whether you're talking about web front end, or in-memory analytics, or very heavy transactional workloads. And then if you look beyond that, in terms of looking at sort of the overall density and capability, Bergamo, again, is significantly better than the competition in compute density and energy efficiency. So what we see is more than double the number of containers per server, and 2 times the energy efficiency in Java workloads. Now, as you can tell, we are incredibly excited about Bergamo as well and the benefits it will bring to our cloud customers. So I'm happy to say that Bergamo is shipping in volume now to our hyperscale customers. And as I said earlier, I always like to talk about how customers are using our solutions. So to hear more about how one of the world's largest cloud companies plans to deploy Bergamo, let me welcome Meta's Vice President of Infrastructure, Alexis Björlund, to the stage.
Hi, Lisa.
Alexis, it's so great to see you. Thank you so much for being here.
It's wonderful being here. Thanks for having us.
Oh, absolutely. I mean, the partnership that we've had with Meta is just incredible. I mean, you guys are known for really pushing the envelope in hyperscale computing, and really combining not just the engineering leadership, but also the commitment to open standards, and frankly, running your infrastructure at scale for lots of applications and billions of people. So can you share a little bit about how we're working together?
Absolutely. So as you know, Meta and AMD have been collaborating on EPYC server design since 2019. These collaborations have been expanding over time with Milan, Genoa, and now Bergamo. We've worked closely to customize AMD's EPYC architecture to meet Meta's power efficiency and compute density requirements. These optimizations include all layers of the hardware and software stack, including Zen cores, SoC composition, firmware, kernel performance, telemetry, and software to deliver best-in-class performance per TCO for our compute infra. We've also shared our learnings around reliability and maintenance and have helped improve the EPYC to server designs for all hyperscale deployments, as well as you know, with all of our platforms, we open source, and we open source the AMD Milan-based server design via the Open Compute project in the past, and we intend to do the same with our latest Bergamo generation high-volume servers. So we really appreciate working together with your team and your support on this.
Oh, absolutely, Alexis. You have a demanding team, let me say, but we love the work that we do with your team. I mean, the deploying infrastructure at your scale does present some unique challenges, and we learned a lot along the way. Can you talk a little bit about some of the work we've done together to address those requirements?
Absolutely. And as you know, we've deployed hundreds of thousands of AMD servers in production across our global data centers and fleet that are running thousands of workloads in service of WhatsApp, Instagram, Facebook, and across our product groups. We've also deployed AMD servers for video transcoding and storage systems and are using AMD CPUs on our AI compute platforms. So as you know, we've shared our workload learnings together with AMD and are working together as we address issues in scaling as they arise. And you're right, our scale is massive, and our scale and our generational ramp rate naturally strains our suppliers. But early on in our partnership, we had concerns about
We were new.
About AMD's ability to scale alongside us and meet our demand as we aggressively built out our data centers. But over the years, AMD has consistently delivered to meet these commitments, whether with your supply or your technical product roadmap innovations. We've been thoroughly impressed, and we've learned that we can rely on AMD to deliver time on time again.
Well, I really want to say on behalf of all of our engineers, thank you for that. We work really hard. We truly value our partnership. And as we've said before, we love learning and co-innovating and co-developing with our partners. And some of the insights from your workload have actually helped us shape what Bergamo should be. So as one of the leading cloud companies, talk about Bergamo and how it fits into your plans.
Absolutely. We are incredibly excited to be preparing to deploy Bergamo as our next generation high-volume general compute platform for Meta. We're seeing significant performance improvements with Bergamo over Milan on the order of 2.5 times.
I'm sorry, did you say 2.5 times?
I did. And it offers substantial TCO improvements over Milan as well. So you make it pretty easy on me, Lisa. We love products that make both our technologists and our business teams happy. So building upon the core silicon innovation that AMD has enabled with Bergamo, we've partnered with AMD to add several other optimizations that help our workloads, including dense compute chiplets, the core-to-cache ratios, power management, and manufacturing optimizations that help us pack a high number of these servers into a rack and deliver rack-level performance per TCO improvements as well. So with the flexibility of your chiplet strategy for Bergamo, we're also pleased to have an I/O-intensive server option that we could leverage for HDD and flash storage platforms. So with our focus on enabling new products for our customers as well as capital efficiency, we're thrilled to unlock the benefits of Bergamo for our entire family of apps.
Well, again, thank you, Alexis. We are so excited to be working closely with you guys on Bergamo and really looking forward to not just deploying Bergamo, but also all that we'll do together in the coming years. So thank you again for joining me today, and thanks for your partnership.
Thanks so much, Lisa.
Thank you. We're so excited to hear stories like this where, Meta is deploying, broadly Bergamo, but most importantly, it's really broadly across the spectrum, including things like, Facebook, Instagram, WhatsApp that we use every day, as well as a number of other services. So as you can tell, we're incredibly proud of our 4th-gen EPYC family, but there's a bit more on the CPU side here. So to tell you more about how we expand our portfolio to deliver leadership in technical computing workloads, let me invite Senior Vice President and General Manager of AMD Server Business, Dan McNamara, to the stage.
Thank you, Lisa, and good morning, everyone. So 1 year ago, June, we rolled out our portfolio for EPYC around optimizing for different workloads. And we are super excited today to be delivering 2 new products. You just saw how we optimized 4th Gen EPYC for cloud-native computing with Bergamo. I'm going to spend some time showing you how we also optimized EPYC for